Let's start chatting through this. So like I was saying yesterday, like the 5-1 stuff where it was like the inequality stuff, they just introduced that with the first lesson there, but then we're not going to use that until we get towards the end of the lesson. So we're going to learn some stuff with systems, and then what we're going to end up doing is we're going to take the inequality stuff and the system stuff and put it all together for like the last couple sections of the chapter 5 stuff. So now we're going to skip to the system stuff. Basically, in general, what a system is it's a set of different equations where you're looking for their intersection. Okay, so a lot of times there's just two equations. So like if we had like y equals whatever, what you could do is just graph those two equations, and then what the solution to this is where those two lines cross each other. Okay, so you might have situations like that. You might also have situations where you got like a graph and you have like a different style of graph, maybe like a parabola type graph, and then you have like, you know, a line or something cutting through there. In that case, you might have multiple solutions. So depending on the type of equation they give us, you could possibly have a couple different answers. And I think one of the examples we do today is kind of like that, where there's a couple different answers. There's also situations, so like say it was that curve, and we had like a line down here. If we had that curve and that line down there, do those even cross at all? No. So you might also have some situations where there's like no answer or no solution, and that's kind of what the parallel is. So like if you had parallel lines and you're looking for where those lines cross each other, do parallel lines cross? No. So what would happen on the calculator if you went to go to try to find the intersection and they were parallel, it's going to give you an error because you're asking for where they intersect, and if they don't intersect, well, it doesn't know what to do, so it gives you an error. So if you do something like this, go and use your graph or your graphing calculator, and it gives you an error, it's probably more than likely because they don't cross and they're like parallel lines. Or it could be a situation like this where you got like that U shape and then, you know, a line down there or something where they don't cross. Multiple different situations there. But basically, in general, system is you got a bunch of equations and you're seeing where they cross each other. So today's stuff, we're just going to focus on just using the graphing calculator for that. I think you guys are fairly familiar with that. If you need me to write down the steps for you later or whatever, I can write down the steps for you too. But hopefully it's stuff that you've done before. So on our graphing calculator, I'm going to avoid where that right spot is. We'll look at this first one. So this should be in your packet. Does everyone have a packet from yesterday? Okay. So here, this one's a nice setup because to be able to use our calculator, we have to have our equations to y equals, so we can use our y equals button. Here it's awesome because both of these are already set up to be y equals, so we can just take those two equations and straight away put them in our calculator. So we'll just go to the y equals button. Zoom it out here a little bit so maybe we can see the buttons a little better. So we'll y equals button, and then you just type your stuff in. So like 3, we know the x is the one under the mode button. And then plus 2, arrow down, 2x, minus 4. Just get those typed in. Then you just hit your graph. So you get something like that probably. Mine might. Is it? Okay. Okay. So everyone do this. Go zoom down to the 6th one, which is the standard. Hit enter and try that. Did that help or hurt?
Mine's still kind of like. Oh, okay. Wait, yours.
Yeah, mine, because I use it all the time, is probably something else. Bring me yours. I'll look at it. Because sometimes when we mess with these and we change like the settings around, sometimes stuff can get messed up. So yours is because you have your scatter plot on. So see there how the plot is highlighted.
Yeah.
So what you would do is you just go up to it, hit enter, and now it's not highlighted. So now it should go off. Thanks. Okay. So here we get something that kind of looks like this. So we know those lines aren't parallel because it looks like they're kind of diagonaling down there. We also know they're not parallel because what do parallel lines always have the same? Slope. So we know they're not parallel even though we can't see where they cross. Do you guys remember how to get it to where we actually see where they cross? So what you can do is if you go back to zoom and you go to zoom out, you can either, so if you go zoom and then zoom out, it's just going to take you back to this. If you hit enter once, it'll zoom it out a little bit. Now can we see where they cross? Yeah, if you hit enter too many times, it'll just keep zooming out, zooming out, zooming out, and then the calculator gets pissy with you because it doesn't want to go that fast. But if you just hit it once, hopefully we can kind of see where they cross there. So now to get the exact spot, what we do is you go second, trace button, because that says calculate above it. So we're going to calculate the intersection. So I went second, trace button. I go down to the fifth one, which is intersect. Hit enter. Then it's going to ask you some questions. For now, I'll explain what the questions are asking. It's asking when it says first curve and second curve, it's asking you to pick like two lines. So like if this was our graph, it's asking you to select this line and select this line. The reason they ask that is, say we did have a situation like this where we graph three different like equations on there or whatever, they want you to pick which ones you're actually specifically asking about, okay? So that's why it asks that stuff, first curve, second curve. In this case, since we only have two lines, you can just hit enter on first curve because it's just going to select the first equation. Hit enter again when it says second curve because, again, we only have two. And then the guess, the reason they have guess there is because if you have a situation like this where there's multiple crossing spots, you want your cursor to be closer to one of them, so it picks that one. And then if you need the other one, you just have to go like to the other one with your cursor, and we can look at that in a little bit if we need to. But for now, since there's only one spot where they cross, we just hit enter again for guess, and it should give us our crossing spot down here. So it should tell us our x is at -6 and our y is at -16. So that's just your solution to that. So it would just be -6, -16. And all that can be done from the calculator, as long as you got your equations and y equals. Does that kind of roughly make sense? All right, so let's take a look at the next one there then. So this one's a story problem, so we got to set up our equations. So we got Fred wants to enclose a 400 square meter rectangular garden with 70 meters of fencing. To do this, he must use one side of his barn as a side of the garden. What can the dimensions of his garden be? Okay, so in this situation here, we got this barn. If we've got a barn and we're putting a fence up to it, do we have to run more fence along this side of the barn here? No, that would be a waste of fencing, right? Because the barn can act as a fence as long as it's, doesn't have any holes in it or whatever. So here, when it says perimeter, technically this isn't really the perimeter because perimeter would also include this side here. So it's not necessarily perimeter. It's just including like that side, and that side for like that 70 meters. So technically I probably shouldn't have it labeled as perimeter, but I think you guys can understand what we're getting at there. And then it says the garden is 400 square meters, so that would be like the area of our garden that we're trying to come up with here to get whatever plants we're putting in there. We need it to be 400 square meters. Because we're dealing with systems of equations, let's establish the W and the L as like X and Y. I'm just going to do it as my W for the width being like my X value and the length being my Y value, just so I can solve for like one of them to be able to graph. So like we would solve for L in this case to be able to graph. It doesn't matter which one's which, technically you'll get the same answers either way. Okay, so let's set up some systems here to meet those two requirements. Meet the requirement of 400 square meters for our total area, and then meet the dimensions of that much for our fencing. Okay, so let's start with the fencing stuff with like perimeter, kind of perimeter. What would we do to find the perimeter there with that, like what I got in orange? What's perimeter mean? Not that. That's area. All the sides added together, right? So here, if we know our perimeter per se, or how much fence we've got is 70 meters, when we set up our equation, wouldn't it be like a total of 70 is equal to this side plus this side plus this side? So like, well, let's start with this. What's W plus W? 2W. So I'm just going to make that 2W plus, and then we just have one of the L's. So just L. Okay, so that kind of sets up our perimeter part of this. Now area, how do we find area? Length times width. So we know our area is supposed to be 400, and area comes from length times width. And even though we don't have that side there, the area would still be the same. And then, like I was saying before, the reason I established like that one of these was the X and one of those was the Y. So when we go to type this in our calculator, what are we going to want to solve for? What letter? The Y, right? Because here we got a Y equals button, right? So we got to get our equations to Y equals. So in our situation, what letter do we want to get by itself? The L. So we want to solve for L. So we have L equals or whatever because that's in our Y position. Okay, so then if we can get it to that, then we can just use our calculator. Okay, so if I take that first one there, 70 is equal to 2W plus L. Oops, it's not a spell. How do we get the L by itself? minus 2w. So then we have 70 minus 2w is equal to L. So then that's one we can use on our calculator. So I'm just going to rewrite my system here with that one instead. So I'm going to go L is equal to 70 minus 2w. Okay, and then the other one there will have 400 is equal to L times w. Okay, how do I get the L by itself there? Divide by w. So then we're just going to leave that as 400 divided by w because there's nothing we can really simplify down there is equal to our L, and we can type that into our calculator, so that should be fine. So then equation-wise in our system, we'll have L is equal to 400 divided by w, and then that new one there is the one we can put in our calculator. So then I would just take those and put them in my calculator. So like the L is standing for the y. So just go back to y equals, clear out our stuff there. We'll go 70 minus 2, 70 minus 2, and then we just have to make it x. And then the other one would just be 400 divided by x. And then we hit our graph again. Okay, so our graph here, it's not necessarily like a parabola like we had up there, but you remember these curve-shaped ones we did a couple chapters ago. What are they called? Hyperbolas, I think is what they're called. But where they're like the curve shape there and the curve shape there. So if this is a curve shape and that's a straight line, isn't there also probably a crossing spot up here somewhere as well? Yeah, so we might want to change like our dimensions here to kind of get this more where it's up in that area. So a couple things you can do. If you go back to zoom and go zoom out, so like you can kind of see a little bit here how I have a little cursor flashing in the middle. You can move that cursor around. So like with your arrows, so if you want it to zoom in on more of a specific area, so say we want it more up in this quadrant, if I do that and hit zoom out, it'll kind of take it to that little quadrant a little bit better. Still kind of hard to see in there, so another option, you could go back to zoom standard. You're not going to be able to see it because these are big numbers, but if we know that it's in this quadrant here and we do our original zooming out, just more in that quadrant. So again, I did zoom out, and then now I'm going to take my little cursor here and kind of get it more in this quadrant. Something kind of like that. I'm hoping that gets us a decent view. Still didn't quite get us there, so maybe I had to zoom out all the way. Up to it a little bit more. Not a great view, I suppose, of it, but we'll go with it. Can you all kind of see that there's like a little spot crossing there and a little spot crossing there? Everybody cool on that? Okay, there's other ways we can kind of get it zoomed here, but if you guys can kind of tell that it's there and there, we'll just go with it. So this is a case where we've got multiple answers. So what we're going to want to do is we're going to want to go second trace again to find our intersect. Go down to that fifth one, which is intersect. Now this is where our selecting is going to be a little bit more important because we have multiple spots. So like my cursor here is kind of towards that upper crossing spot. So I'm just going to hit enter for first curve. Looks like my cursor is still kind of close to that. So if I hit enter again and then enter again, that gives me a rough estimate of where that spot's going to be. So one of our things here is going to be, we're running out of room here, 7.19, we'll just round to there, and 55.62-ish, somewhere in there. So that's one option. Then if I go back here and now I want to try to get to this other option, you do the same thing. So you go second trace and intersect, but now when it's asking that, my cursor's still up there. I want to take my cursor and slide it down where it's closer to the other one, then hit enter, and then my cursor kind of stays down there. So it is the right and left arrow, I think. Did that work? The up and down arrows jump lines. So if you do the up and down arrows, if you had like 3 or 4 lines you had to pick from, that jumps from line to line. The right and left one slides it on the graph. The reason it's the right and left ones is because you're sliding your x value. So that's why it does that. So you're sliding your x kind of down the line. So you can kind of see that there and there. But as long as you get them closer to the second one you're shooting for compared to the first one, you should be okay. So you just hit enter. Yes, it should still be pretty close in there. Hit enter again. And another possible option here is like 27.81 and 14.38-ish. So for the purpose of our problem, this would be about like a 7 meter by a 55 meter situation. So like if we did have like our little barn set up here, it'd be like about 7 by about 55. And the other one would be about 27, 28-ish by about 14-ish. So just depending on how you want it and what you've got for like land available, those would be your two options that you could have for like the setup of your little garden area. Okay? Alright, so that's it. So like I said, use the calculator when you can, because that's very helpful with this graphing stuff. If it said, I don't know if any of it says graph by hand, but if you need some graph paper, there's plenty of it over there. You can just sketch graphs of it too, it's fine. We'll go on to the next section of substitution, but it's the same thing where it's like these systems and then you're just figuring out where they cross each other. So working on that book page, you're going to skip quite a few because there was a lot of weird ones in there. So skip number 3, 5C, 7B, and 14B. Okay, so a lot of kind of odd ones in there I just had to get rid of.